This is Bob Capetto, and this lesson is on logic, statements, and negations. So what is a statement in logic? A statement is a sentence that is either true or false. So it has to have a truth value. So I could say something that's true. For example, I could say Tallahassee is the capital of Florida. That has a truth value of true, or a value of true. I could say something that is false. For example, I could say that the Seattle Mariners play all their home games in Russia. That's a false statement. So a statement is not an opinion. It is not something people may debate. A statement has to have a truth value. Either it's true or it's false. Now, we tend to indicate statements with letters. So we could have a P could be what statement? P could be the statement that Trump is the US president. So depending on when you're watching this video, this is either true or it's false. Q could be the statement that Washington, D.C. is the national capital. And again, you can determine whether they're true or false statements, but we can also use negations. So what is not P? So P tells us that Trump is the US president, so what would not P be? We don't say not Trump is the US president, we would say Trump is not the US president. So the symbols that we use for the statement, we use a symbol P. For the negation, we use the symbol not P. So it's a basic fundamental notion of logic, or notions of statements. A statement is either true or it's false. It's not ambiguous. It's not an opinion. It's not a command. It is a statement, like the ones that we're looking for. But where this gets interesting is when we introduce quantifiers. So we have two quantifiers. We have the notion of all and we have the notion of some. So what are some examples of some statements that are all statements, or some statements that are either true or false? I could say all chickens are birds. And how do we visualize that? We can visualize that with the Venn diagram. All chickens are birds. This would be the set of birds out here. And this would be the set of chickens on the inside. So that would be our case that all chickens are birds. So if we're going to use our notation, we'll say all P. Then the question becomes, how do we negate this statement? If that is not true that all chickens are birds, what is the opposite of all chickens are birds? Is it that no chickens are birds? Well, not really. What's it going to be if we're going to take the negation? So trying to negate that, we're going to say, well, that's not the case. All chickens are not birds. So if I have chickens here, and I have birds here, and I at least have something out here, we have some chickens that are not birds. So the negation of all P is what? Is some chickens are not birds. So what would that be? That'd be some, not P. Again, that's the notation that we use. So for negation, we put a little squiggle in front of something. So P is our event, not P is squiggle P. So the way we negate a statement is we do what? We go ahead and put a squiggle in front of it. But to go from all P, some, not P, would be the negation of that. So let's look at another example of that. What if I said, all restaurants in town are open at noon? Whether this is true or not is not relevant. That is our statement P, okay? So this is our statement P. How do we negate that? Some, not P. So the negation, so all P, so we have all P. So the negation of all P is some, not P. So how do we go ahead and rewrite that in words? We would say some restaurants in town are not open at noon. That would be the natural way for us to describe that process. So again, if we want to clarify this notion, the negation of all P is some, not P. That's something to keep in mind for us. All right, let's take a look at another idea. What if we say, some cars are red? So our idea here is now some P. How are we going to negate that? What's the negation of some cars are red? Think about that for a minute. Does that mean no cars are red? Does that mean all cars are red? Does that mean all cars are not red? Does that mean some cars are not red? What does the negation of some cars are red? So if we're thinking of this, we're thinking what? We're thinking there is an overlap between cars and red. So we've got cars here, and we've got red here. We think there's an overlap, so there's at least some items in this situation. If that is not true, if I negate that idea, what happens? What happens to this? If I negate that statement, if I look at the Venn diagram, the cars and the red are separated with no overlap. So I have some cars are red, some P in this situation. So the negation of that would be what? Would be all cars are not red. So the negation of some cars are red becomes all cars are not red. So basically, the negation of some P is all not P. That's a way for us to think about that. Now, there's one thing that can make this a little bit tricky. What if I say the following? What if I say no man is honest? Now, again, this has to be a true statement or a false statement, so you've got to make sure that we can define that. So let's say for the sake of our discussion, we say honest means always tells the truth. I'm saying no man is honest. No man is honest. Is there another way that I can say that? No man is honest. What is an equivalent way of saying this? I don't want to negate this yet. This means what? No man is honest means all men are not honest. Right? So all men are not honest. So if I want to negate that statement, how do I negate all men are not honest? Negate all P. How do I negate all P? If I negate all P, what do I get? What does that become? That means some, not P. Well, all men are not honest. So the P statement is men are not honest. If I negate that, men are not honest, what does that give me? That gives me honest, not of not, right? Think about it this way. The negation of the negation of P is just equivalent to P. So if I take the negation of this, all men, so we're going to take the negation of that, negation of all men are honest, which is equivalent to no man is honest. Some, not P. Some men are, take the negation of what follows, not honest. Just to emphasize this. So what can I say? Not honest, of course, would mean honest in our discussion here. The negation of the negation is just a statement. Some men are honest. So look at the original statement, look at the negation. The original statement was no man is honest. And the negation is some men are honest. Maybe that's easy to see. I like to rewrite no man is honest as all men are not honest. Change the all to some and the negation to what follows. The negation of not honest becomes honest. Negation flips all to some. Not honest becomes honest. So let's clarify these concepts here as we look at one or two more examples. So how do we, generally speaking, negate these statements, negations of quantified statements? If I want to negate all A are B, the negation is equivalent to the negation of that. Negation is what? Negation becomes some A are not B. So that's where the negation goes. If I want to negate some A are B, What does the negation do to that? Some becomes all A are not B. Which, by the way, is equivalent to no A are B. So no A are B is equivalent to all A are not B. And notice the negations go the other way. If I start with some A are not B, the negation going the other way would be all A are not B, all A are B. So you can sort of think of the negations going both ways here. So let's take a look at one or two more of these. What if I say some forks are not plastic? And I want to take the negation. Okay, so what I have is I have some A are B, some A forks are B not plastic. Okay, how do I negate some A are B? All A are not B. So the negation of that, the negation will be all A are not B. So what was A? A was forks. So all forks are not B. What was B? Not plastic, not plastic. And again, remember not cancel each other out, and our result is all forks are plastic. Which of course is a ridiculous statement. I can just look in my kitchen and find some that are not plastic. I can also find some that are plastic. So in terms of the truth value, some forks are not plastic. That's a true statement. All forks are plastic is a false statement. Well, when you negate something, if you negate a true statement, it becomes false. If you negate a false statement, it should become true. And let's do one more similar to that. And I will say all professional athletes are tall. Again, if this is a statement, we have to agree what tall means. Maybe tall means over 5'6". Again, it doesn't matter whether this is a true statement or a false statement. It's just got to be something that we can agree on. So in the case of our tall, we're going to define tall as over 5'6". Not terribly tall, but that's going to be our definition. So we've got all A are B. Right? All A are B. The A part is professional athletes. The B part is tall. How do I negate all A are B? How do I negate all A are B? Some A are not B. Are not B. Our A is professional athletes. Some professional athletes are not B, are not tall. That is the negation, right? So this takes the negation of that first statement. Now again, where this gets tricky is if I say no. If I say no. So let's finish this up with the following. No fast food meal is less than 500 calories. Again, it's got to be what? It's got to be well defined. It's got to have a truth statement of either a truth value of either true or false. Now, to me, no are more challenging. So if I have no A or B, that is equivalent to all A are not B. So all A, if I'm going to make the equivalent before the negation, all A, all fast food meals are not less than 500 calories. Okay, all A are B. How do we negate all A are B? Some A are not B. To do the negation, that's how we do the negation of the quantified statement. Some A, what is my A? Some fast food meals okay, B was not less than 500 calories. So not less than 500 calories. Not would be are less than 500 calories. So what I want you to take from this lesson is a statement must either be true or false, not an opinion, not a suggestion, not a command, true or false statement. And then how do we negate things? Our key idea to negate things was here. If I have all A are B, if I want to negate that, that is some A are not B. Some A are B, if I want to negate that, that means all A are not B. So some becomes all, and then you follow it with the not. That's our basic idea. So to kind of highlight this notion, I like to think about it this way. Again, the negation of all P. The negation of all P is some not P. The negation of some P is all not P. How about if I want the negation of no P? Well, here's the thing. No P is equivalent to all not P. So this is the negation of all not P. The negation of all not P is some. Take the negation of not P. The negation of not P gives me P. And that will conclude this lesson.